I want to show you that we can use pointers in structs, and this is going to be very useful because it allows us to create data types like linked lists. So to create a struct, you just write the keyword struct, and let's call it node, because we're going to write a very simple linked list program here. So within node, we're going to have three pieces of data. We're going to have int key, which will hold the key index. Then we'll have int value, which will hold our value. And then let's write struct node. It's going to hold a version of itself within it, but this is going to be a pointer, and it's going to be called next. This is basically what a linked list is. It'll point to the next node in the list. So let's start off by just making a struct node pointer, and this will be our node pointer. Then let's create struct node. This will be called my node. Now let's do struct node next node. So this will be the node that we start with, and then this will be the next node that this node will point to. So this will point to the next node. Let's start off by assigning the value of the first node, and let's just store it in our pointer. So let's do pointer node is equal to the address of my node. And now we'll do node pointer, and access the key, the value, and the next members in our struct. We're going to have to use an arrow notation because this is a pointer. So we're going to have to do dash greater than sign key, and we'll make it equal to, let's just say 42, and then node pointer value, we'll make it equal to 99. And now we're going to create our second node. We'll do node pointer next, and we're going to assign next, which is the next value, to our next node. Next node. But we're going to use the ampersand to give it the address. And now here we can access the next node's values within our current pointer. So here we could do node pointer next pointer key. So now we're accessing the value of next node from our initial pointer. So here let's just make it equal to 55, random value, and then we'll do node pointer next value is equal to, let's say, 88, and then we'll do node pointer next. So the next value will just be equal to null. So this will be the end of our list here. So now let's print out all the values in our linked list. To do this, we're going to have to grab our current pointer that we're going to reassign. So let's make a new struct node pointer. So let's do struct node pointer. We'll make this equal to current, and we'll make this equal to node pointer. So we'll start off with our first node, which would be my node, and then it'll go to the next node, and then it'll go to the next node, which is null, so it'll stop there. So now we'll just write a while loop. While current not equal to null, we'll print out the values in our current node. So we'll do print f, and we'll say node key %d, comma value %d, new line. And then here we'll write current arrow to the key for the first %d, and then for the second %d we'll do current pointer to the value. And after we print it out, we're going to make current equal to the next node, so we could print out the next node the next time the loop runs. So we'll do current is equal to current arrow next. So in this case, once we hit the next node value, its next is currently equal to null. So when we hit that, it'll say current is equal to null, it'll break the loop, and it'll keep going. So if we save this and we run it, we can see we have node 4299, which is the first one, and then we have 5588, which is the next one, and then it'll break there because the next node, which is this variable here, has the value of null, so it'll break the loop there and won't print any more nodes. This is sort of the main purpose of pointers, so we can create complex data structures like this. This is not a complete implementation of linked lists, but we'll get to that later on in the program.